Yo, Danny, you here?
Hello. Oh, hey, what's up, guys?
Hey,
Or
no, so me and Iram were in a Google Meet. I don't know if anyone is going to be able to hear what we're saying right now. But
maybe.
yeah, also, okay, awesome. Yo, Danny, you here? Oh, wait,
Wait.
I have to mute that.
Yeah.
that was that was the stream.
Oh, all right. I was like, what the heck? We went back in time.
Yeah.
Oh, hello. I think she joined.
Yes, Iram, good to see you again.
Hello.
Hey, one of our
Video.
yes,
Okay.
I'll share myself as well. Um, one of our team members wanted to join in really quick just to help out, make sure things are good. Is Danny. He
Hello,
is
Danny.
our team.
So, how's it going?
Good. Great.
A little
Oh,
nervous?
so. Will I share my screen? Other, we try.
Yeah, you can. Yeah, you could try sharing your screen if you would like. Let me stop sharing mine. Um, let me give me a second. I am okay. Yeah, you can go ahead and you can try.
Oh, okay. 1 minute.
Yeah, this is your first international talk, right?
First international talk through. Host disable screen sharing. Other.
The
Oh,
screen share.
I have to enable screen sharing. Give me a second. I could figure that out. So, um, advanced options. All participants.
We are YouTube live now.
I think. Yeah, I think we should be live. Okay, yeah, you should be. You
Yeah.
should. Okay. Um.
Um,
Alright. Hey everyone, welcome to the talk so far. I'm glad to see you guys in chat. Uh, hope everyone is having a great Saturday, whether if it's night by you or day. Um, if you guys could say in chat where you're from, that would be greatly appreciated. I know there's people from all over the world going to be watching the stream, so excited to see where everyone's from. Uh, yeah, it definitely will be big brain time. Yeah, I yes. Our first workshop and a talk for the semester. Definitely big hype. Um, Also, sorry if you guys can hear the blower by my area. If only I could tell him to stop doing that, but um, Let me see. Let me see where you guys are from. Let me see. Miami, Turkey, India. Ooh, ooh. Nice, nice. Awesome. We're gonna wait a few minutes before we start so that people can join it in and whatnot. Kuwait, that is so cool. Nice. Miami 305. Or you guys 754, 954, 786. What do you guys represent? Also, I don't know if there are any Avatar watchers in here, but I'm representing you guys today. Um, you know, Earth. Yes. Glad you're from Earth, Paul. Yeah, yeah. Dale, yes, go Miami. Mm-hmm. That's where we're from. Yeah. Um, three. Oh, okay. Um, cool. I think, Irem, if you don't mind, I think maybe we could start doing some introductions, and then if you'd like, we could get started. How does that sound? Mm,
Yeah, I start.
okay.
Okay.
All right. Okay. Awesome. Well, thank you all so much. Love seeing you guys in the chat. For making it to our very first event for the semester, computer vision with deep learning. Um, well, I'm gonna introduce ourselves really quick. Uh, my name is Azar Ali, and I am the president of the Google Developer Student Club at FIU. Um, and joined by me is Irem Komarucu. She is a computer vision engineer from Turkey. She's been featured on the Google developers blog, and she is a super awesome engineer, skilled in computer vision. And without a further of ado, I'm going to pass the mic to Irem. Irem,
Thank you, Azar.
yeah.
I am really excited. And hello, everyone. I hope you have a nice presentation. And I am just feeling excited now. And I think let's start fast. What will we talk about today? Today, there are popular terms, and we all deep learning, machine learning, artificial intelligence, computer vision, and what is the difference between these terms, or where do we use these terms, and what is computer vision, in which technologies we use computer vision, TensorFlow, Keras, a framework for computer vision, various application models, function, and we will talk about various topics similar to those I listed. And me, who am I? I am Irem, and I am computer engineer, and I especially work on computer vision and deep learning. And if I have to give, detail, segmentation, classification with remote sensing data is my main area. And I have been working with Google developers and women tech makers team for more than 4 years, very long time. And so I have also worked with DST teams, and I made more than 30 presentations on various topics in my country, in Turkey, and now I am so excited, really so excited, and I have uh, two reasons to be excited. First, today is my birthday, and other reasons. This is my first global and with English language presentation, and that's all from me. And let's start computer vision. Now see three basic concepts, and artificial intelligence, machine learning, and deep learning. And actually, we can include data in here, and we should understand that all these terms are part of artificial intelligence umbrella. And if we need to talk a little bit about artificial intelligence, refers to the human, refers simulation of human. And I know when here to term of artificial intelligence, the first thing that usually think of is robots or highly advanced systems, but unfortunately, the facts are not exactly like this. Artificial intelligence makes it possible for machines to learn from experience and perform human-like tasks and adjust to new inputs. And most AI examples that heavily on deep learning and specifically and natural language processing. And actually, in the last 10 years, there have been advances in artificial intelligence thanks to deep learning. So this is a machine learning example. And in machine learning processes, we basically give input to mathematical operations and expect prediction output. An easy example of machine learning algorithm is email services. Email services use machine learning to filter incoming emails, and users can train their spam filters by marketing emails as spam. And this is big and popular machine learning example, email spam. And deep learning as is main important and main subjects. I'm so excited again. Deep learning has been with us since 2010, and deep learning has been a field that adds a lot to artificial intelligence, and it is just a subset of machine learning and deep learning. No, and artificial intelligence and machine learning and deep learning is what powers the most human-like artificial intelligence. And it inspired to actually human and human nerve cells and other named neurons, and there is an exchange of information between neurons in our brain, and this is also on the basis of deep learning and neurons and brain nerve cells. And we set up neural networks with deep learning. It has now you are seeing one deep learning example, and it has neural network layers, and these layers have weights. And learning occurs thanks to weights and transmission for deep learning. it basically consists of the input image, hidden layer, weights, and output layer. And now you are same. And deep learning has brought many popular areas. We use deep learning in many areas, and in example are our phone in camera filters, phone class system, assistant or computer vision, self-driving, speech and various sound technologies, image processing, military files, advertising, social media channels, and many areas use deep learning and machine learning. And this is an example of deep learning. This network have one input image, and then data pass different layer. Different layer, max pooling layer, convolution layer, fully connected layer, doesn't matter. Data pass different layer. Then we see process result. The output or result depends on what do you want and what you train. This is important. What you want and what you train. This example can be contour detection by face shape, or this example can be diseases detection by face shape, and what you want and what you train. Actually, this is an example of K features. And second example, the pictures are vivid. There are important and teeny details from the pictures. Actually, this is feature extraction and K features example. And for example, like in first visual has a noise, eyes, or mouth case were found, and this is K features or feature extraction example. And pixels. Pixel is most important term for image processing and computer vision. Pixel actually tells us a lot, and brightness, location, data extension, color balance, bit depth, resolution, and more are given to us in pixels. And there are many image formats and color spaces, and these are important in your process. I will explain in detail why pixels are so important, but first let's look at the concept of computer vision. And computer vision, deep dive and computer vision. With computer vision technologies, we want to do things we do with the human eye and try to eyes of computer. Yeah, computer eye and human eye. And computer vision has many areas, and segmentation, classification, image processing, feature extraction are just some computer vision area. And I just gave a K feature extraction example, or I just counter classification based on face shape. And these examples are so also in the field on computer vision. And with computer vision, we can do many studies in many other areas, and I will give more examples. After talking about pixels, we should talk about the concept of noise. Sometimes our image or data sets has noise. We can say noises are tiny flaws in our image data. This station is sometimes good, but sometimes bad for computer vision developer engineer, because example, noise creates diversity in our data. This is good for computer vision engineer developer, but sometimes the noise creates meaningless data in data set, and this is not good and not preferred. And our main and our important subject, images are numbers, and my photo says hello to you. And then again, actually, images are numbers. I can hear you say how does, and uh, actually, images are seen by the computer as numbers. I said how important pixels are to us, and each pixel actually represents a number. And for example, now you are seeing a black and white image, and in this picture, each pixel takes a value between 0 to 255, and the computer sees the values and 255. And on the left is a normal image with clear pixels, and on the right number, each pixel value gets. And the computer sees the image as on the right, and images are numbers. Let's look at the image again to understand better. And we have an input image, and the computer sees these images as numbers, and actually we can call it a matrix or vector. You are seeing now, and then we can do various computer vision tasks with computer vision. For example, classification has been done here, and classification is also a computer vision process. Okay. What we learned now. We learned images and pixels, and we learned that every pixel value is number, and we learned that an image is actually a vector or a matrix, and now you are seeing number 8 and vectors. Let's dive into subject a little more. Each number, each visual has a different sequence. I want you to dream now, and if I ask you to draw 0 or 3, 5, 9, it doesn't matter. Everyone would draw example 0 differently. And now, as you can see on the right, each shape is different, which give us different vector sequence. In example, just like you see here, and writes the number 8 is in all image, and also all is different. This number has similar sequence structure, but look at the right, you can see similar sequence structure, but this is how computer vision sees images, interprets them like, and and makes inference like this. And this is basic logic of the work I am telling you, and computer sees in this sequence and structure. This is a prediction example, and a number is right in the draw here filed, and the prediction is output. Yeah, the visual prediction have been processed in the same way that I have explained at the previous slides. And then we got to output, and basically this is the foundation of image processing and computer vision. Now let's talk about the popular areas of computer vision and where do we use the computer vision. For example, one area of use image classification and localization, and we will understand more clearly in the next slides. For example, this is an example of binary classification. Binary because cat or dog is our output, and we have the input image. Now you are seeing, and we have input image, and this input image is entering at deep neural networks, and it goes throughout various processes and layer in the deep neural network. And our deep neural network here simply consists of the input layer, output layer, and activated neurons. As a result, binary classification process has turned to us. The result is either a cat or a dog. So it is classification example, and this could happen within multiple objects, but this is binary result example. If we also did the location determination on the same entry, we could call it classification and localization. But this example is only a classification example. And object detection. Object detection is one of the famous computer vision area, and I often see object detection processes. And in fact, it is a combination of object detection is image classification and object localization process. And it works with bounding boxes. You know you are seeing in this image, and bounding boxes can give us object name, accuracy value, maybe accuracy value, and localization information. And I wanted to give some object detection methods here, and some of the methods I listed on the left, and methods that are frequently used, and especially YOLO SSD are one of the most used methods, and those who work with object detection have definitely seen these methods. And if you want to work on object detection, I suggest you search the files on the left and some object detection methods. Then object detection datasets. The ones on the left are some datasets used for object detection. And here on the left is 1 minute, yeah. Here on the left is a list of free image datasets for object detection, for computer vision, that you can choose from. If you want to work on object detection, I suggest you use the files on the left, and I suggest the dataset object detection free datasets. And then style transfer. Style transfer is one of the areas of computer vision that we frequently see in social media. Yeah, there is an example on the next slide. Look at this. First image is input image, and second image is desired style, and style can be added to desired image with style transfer. And this example is style transfer example. Then segmentation example. This is a segmentation example, building segmentation example with remote sensing data. And actually, this is my first working area, and it is possible to perform computer vision operations with remote sensing data. For example, damage detection can be made with remote sensing data before and after earthquake. Yeah, earthquake, and security measures in military areas can be provided with remote sensing data and with segmentation and remote sensing data. This is an example of building segmentation in remote sensing data example again, and input image on the left, and there is a mask in the middle, and to the right is the prediction output. Yeah, my cat. input image, mask, and prediction output. And we can get accuracy by comparing mask and prediction outputs. Can you, my cat voice? Okay.
Sounds great. She sounds interested.
Okay. We will examine in more detail. And next, TensorFlow. TensorFlow like data flow, and we can call the multidimensional matrix tensor. And TensorFlow is Python friendly end-to-end and open source library for machine learning. And open source code is something preferred and loved by developers. And TensorFlow also offers community support. And you can discuss and contribute about TensorFlow. And sample codes are also available on the TensorFlow official website. And TensorFlow created by Google Brain team. And TensorFlow 2.0 released in October 2019. This is actually new, and TensorFlow supports many languages. Examples: Java, Go, C++, Python, and much more language. But its most stable support is the only Python language, and TensorFlow 2.0 will be simply and easy to use for all users and all platforms. And other information. And Google Cloud Platform or various Google Cloud tools or Colab can be used easily for TensorFlow. And there are special TensorFlow APIs for mobile, web, or embedded system developers. And TensorFlow is so friendly for developers, I think. Now, now the current and stable TensorFlow version is 2.31, and in September 2019, the transition to TensorFlow 2. And TensorFlow and Keras can be used together easily. And now you are seeing in this code and TensorFlow and Keras together. And TensorFlow 2.0 makes development of ML application much easier and makes the experience of developing application as familiar as possible for Python developers, or recommending using Keras. And TensorFlow and Keras will focus easy model building and easy execution and TensorFlow Keras information. We can use TensorFlow, Keras, PyTorch, MXNet, Coffee, or other framework for deep learning processes. And but today I will explain examples of deep learning processes using TensorFlow and Keras. And TensorFlow Keras is my today presentation, our main subject for this presentation. And with the help of TensorFlow Keras framework, we can easily do various operations. And TensorFlow Keras is support data preprocessing, model applications, layer optimizers, and much more processes. And I will now explain all these terms. Example, data preprocessing. And As a data scientist or machine learning engineer or deep learning engineer, computer vision engineer, it doesn't matter. You can spend a good amount of your time preparing the data before you build your learning model. And we talk about the concept of noise and data. And usually we need to pre-process the data we do this within the model. And pre-processing our data can improve our results, and this is something we prefer. And image processing, image pre-processing could be simple tasks like image resizing, removing noise, filtering, pixel brightness, or histogram, or many more techniques and for data pre-processing. And then TensorFlow Keras applications. It's so important because TensorFlow and Keras offers us a variety of applications. These are ready-made models and can be imported on codes and used. And application seriously affects our model success. You can choose a model according to your operations, and you can make change on the model. And now you see some models that are ready to use in TensorFlow and Keras, and these are just some of the most commonly used models. And uh, and we have more models than what I wrote here, and you can access and use these models from Maria's GitHub section and TensorFlow Keras official page. By the way, hyperparameters, number of parameters, and how it takes the data layer content is important in model selection. And each model contains different algorithm and layer. And ResNet 50 model you see on the right now. And inception and other application example. Using our model is that easy with TensorFlow and Keras. For example, here, inception application is important, and various parameters can be entered and used, and you are seen. And you can see the inception model image below, and we saw ResNet 50 in the previous slides, and please notice that it's different from ResNet 50. And this is how we use the model in our code, and the application is so important and so important for developers. And optimizer. Optimizer seriously affects result in optimizers, and optimizers like Adam, Ada Delta, RMS Prop, and what you see on the screen are some optimizers we use frequently. And each optimizer contains a different mathematical formula, and according to data, we need to choose an optimizer according to the actions we take. And on the right, you see optimizer usage. And if we need to interpret the code, first we create models, then add optimizer with learning rate value, and finally a model compile with loss function and optimizers. And this is optimizer and then loss function. In the previous slide, we saw the use of the loss function with optimizer. Yeah, and a loss function must be chosen when calculating the error of the model during the optimization process. Loss function should also be selected according to our transaction and our process. And each loss function has a mathematical formula and different mathematical formula. And for example, we can use binary cross entropy in a classification operation whose result is binary. But if our output is multi-class, it will be better to use categorical loss function. And if we need to interpret the code, first we import TensorFlow and Keras, and then create model and at various layer. Then compile model with loss function and optimizer, and loss function, that's it. And next, callbacks. I think the callback function is important and code friendly. We can include various functions that make our work easier in the callback function and use them during the train operation. Here, early stopping, checkpoints, and TensorBoard are used within the callback function. Yeah, early stopping, checkpoints, and TensorBoard are used within the callback function. To explain a little bit, first, early stopping. Early stopping requires the selection of the performance measure. Yeah, performance measure. And if our training stops learning, we can use early stopping. And other example, model checkpoints. With the model checkpoint function, we can take checkpoints during training. And for example, we can save every best way with a checkpoint on the file we want, and model checkpoints so code friendly and so important, I think. And TensorBoard. I will explain the TensorBoard in more detail soon, but I can talk a little for TensorBoard. TensorBoard is visualized for results, result metrics, model graph, and much more, and visualized tool. I will tell you about the TensorBoard again soon, and callbacks, it's done, and we can use these things in callbacks, and it is enough to use the callbacks function during the fit or train operation to do all these operations, and then metrics. We get output metrics in during training operations, and metrics give us accuracy. We have many metric values, for example, accuracy, F1 score, loss function, IIU score, precision, recall, and all these metric values are calculated with different formula. We have parameters such as true positive, true negative, false negative, false positive. For example, if the predicted and ground truth areas overlap, we call it true positive. Or if the predicted and ground truth areas don't overlap, we call it true negative. For example, now you see the calculation for the IOU metric value. If we divide overlap area and area of union, we get the value of IOU score. Yeah, if we divide overlap area and area of union, get the value of IOU score. And we generally base the IOU value for segmentation operations. This is detail. And IOU score, very important metric for segmentation. By the way, again, it is detailed information. If our process was object detection, we could base F1 score generally. This is so detailed. and TensorBoard. During the training processes and epochs process, and it is difficult to follow transaction from them, so we can use TensorBoard. TensorBoard provides the visualization for matrix value, graph model, histograms of weights, and much more. And it is fun and easy to trade with the TensorBoard. And we usually recommend it trading with a TensorBoard, and so developer friendly, I think. And TensorFlow JS and spatial TensorFlow supporting. Spatial TensorFlow supporting web, embedded, mobile, and much more. TensorFlow JS is a library for machine learning in JavaScript. And if we use machine learning directly in the browser or in Node.js with TensorFlow JS, and we can develop ML models in JavaScript. And I think what's done with TensorFlow JS is pretty fun. Yeah. Here you can see some projects made using TensorFlow JS, and there are projects with web and deep learning together. So pretty fun. And you can see real-time projects with TensorFlow JS, and these project examples are on the official TensorFlow page. You can access open source codes and demos on the official TensorFlow page. And next. If you want to use TensorFlow JS, you need to include this script or installation from NPM tools. I am planning to write articles and do operations about TensorFlow JS soon, and I think it's a fun subject, and I think. And the last topic of this presentation, TensorFlow Lite. TensorFlow Lite is open source deep learning framework for on-device inference. And TensorFlow Lite is a set of tools to help developers run TensorFlow models on mobile, embedded, and IoT devices. And we all use many mobile apps. And we want from a mobile application secure, minimum power, lightweight, or faster inferences. And it's TensorFlow Lite enables on-device machine learning inference with low latency and small binary size. If you look at TensorFlow Lite's usage, and can try it quickly on your devices. Android, iOS, Raspberry, it doesn't matter. And codes are open source and ready to use in TensorFlow official website. And you can try it by downloading it from the TensorFlow Lite page. And this is TensorFlow Lite examples. And thank you. If you have any question, you can ask me from social media or mail, and I have all my social media accounts on my websites, and from there we can interact. And I hope the presentation was useful for all, and I was very excited during the presentation, and I hope it was good time for all. And if you have any question, be sure to ask me, and from social media or my email. And thank you for a lot.
Yes. Thank you so much, Urem, for your presentation. It was so interesting on everything that you taught everyone today. I'm personally definitely going to check out all of this information on my own and get more into computer vision myself. So thank you so much
Welcome.
for everything. It's super interesting. Also, thank you guys in chat for talking. Also, happy birthday again. A bunch of people in chat also said happy birthday as well. So, um, yes, I think, yeah, if you guys have any questions, I will repost Urem's social media information. This is our Instagram. This is Twitter, LinkedIn, and yeah, if you guys also want, if you you could reach out to Iram also on the social media that she put on her slides. If by chance you guys have anything you want us to reach out to Iram as well, we'll connect as well. But yeah, thank you so much, guys. I hope you guys have a great rest of the day. If there's no questions, we're going to end the live stream now. So awesome. Thank you guys so much.
Okay.
I hope you guys